Just a quick note, from now on, at the intermission, there will be cookies and tea served. So, just for your information, except today, this morning, but from this afternoon onwards, we will have cookies and tea served at the intermission.
So, but then how do you know if they're coming back to hear us or they're coming back for the cookies?
Either way is okay for me.
Okay, well, thanks for coming back. So we've got about 55 minutes left. So I just want to talk a little bit more about, and I'm mindful of the fact that some lectures happening here, and I don't want you to think, you know, she said lecture isn't that great, and she spent a lot of time lecturing. So I'm going to get you busy again here shortly, but I've very much appreciated your questions and your comments, so keep doing that. I really appreciate that, and I think it makes for a better discussion. So, instructional methods you often see in college classrooms. We've talked about a number of these at this point. The most typical are a traditional lecture, problem or a case-based kind of learning model where you give students a challenging problem or you give them some sort of case. Like in business, you might give them a particular case to analyze, and then discussion and collaborative learning kinds of models. So let's check our comprehension here. And I sort of gave some of these answers away. So if you think about a traditional lecture, if you look down here, how do we know if it's good? Well, one of the things that it does is it helps learners direct their attention to key concepts. So a very good lecturer is somebody who would say, who does this kind of naturally to say, okay, now, this is really important. Let's think about this. So lectures, even the kind of traditional lectures that you might think about, you can do a lot to help learners say, to understand that, okay, she's spending a lot of time on this. He's spending a lot of time on this. He's making it clear that these are key concepts. So lecture can be a good way to really make clear particular key concepts. It can also help in making connections with things that have been discussed previously. So a good lecturer is somebody who says, now, remember when we talked about this? Now, let's think about what we're talking about right now and talk about the connections between prior knowledge and what's happening right here. So helping the learners to make connections is something that good lecturers can do pretty well. And then developing a structural understanding. A lot of times people will lecture to create a framework, to put some sort of structure in place that then the learners can do something with that structure to make it meaningful for themselves. Okay, so remember our theories of learning. This is the quiz part. Which theories of learning mostly inform a traditional lecture? And let's say good lectures, lectures that are pretty good. Which particular theories are most relevant here? So that top question, the theories question mark, what do you think? If you had to match it up, how would you match up traditional lecture and which theories of learning? Behavioral, absolutely. So it tends to be very behavioral. Anything else?
Information processing.
Excellent, information processing. So those are probably the two primary ones, right? So you're dealing with an information processing model and a behavioral view, which the two are kind of related and build on one another. So, very good. Okay. Okay, so problem or case-based learning, very different than a traditional lecture. There's typically an engaging problem. There's sort of a rich learning environment in which the students are engaged. There's the modeling of problem solving by the instructor. There's often some type of reflection on their learning as they go, sort of processing things as they go. And validation by comparison with some expert solutions. So if you think about a business school, we've given the students some financial scenario that they had to analyze. Very often this comes from a real case, something that actually happened. And so there is some sort of solution, but the solution is not shared until typically later to give the students some sense of their analysis compared to what might have been an expert analysis. Okay, so which theories of learning are relevant here? Constructivist? Okay. Social constructivism? Good. Anything else?
There is also a bit of lecturing in Atılım. So behavioral and information.
So maybe like an information processing kind of thing. I'm thinking about this particular one here, where you might see some suggestions by the professor that here might be a way to think about it, but not necessarily. So maybe on something like that. The dominant ones are what you first came up with. It's constructivist and social constructivist. Okay? How would you decide social versus social constructivist versus constructivist? What's the variable that helps us figure out which one is going on here? Which one you're learning? Which one's
Position of the lecturer.
Engaging more students.
So more students, so the peers are coming into play in a very dominant way, because you know, in some cases students can be given challenging problems and they do spend some time with their peers, but then they spend more time on their own making sense of it. So the constructivist process may also come into play here. So it's the dominance of the peers in the process that would make the difference. But for all intents and purposes, these fine discriminations of which theory, there's a lot of people, psychologists worry about this sort of thing. But the bottom line for most faculty is, what's the best method of matching up what I want my students to be able to do at the end, and to think through that particular kind of theory. And I'm kind of eclectic in many ways. I think it's okay to spend a little time lecturing because you got to lay some foundation. Then you might ask them to do something on their own, like write a 1-minute paper. What did you just learn? That's constructivist. Then you might go to having them work together on a complex problem. And you might move around in these different theories, all of which are appropriate, and all intended to serve the ultimate goal of meeting the needs of the students and where you want them to go in their learning. Okay, one more. Just basic, collaborative learning. I've done some of that today. Getting your students to work together on something. And then there's also discussion. It can be more student-led discussion, or it can be instructor-led discussion, where the faculty, basically your whole class is about you posing questions. And so you talk a little, they talk a lot. But you are very, very much framing these questions. And oh, by the way, a lot of faculty think that writing the discussion's easy. Just go in and you'll wing it. You just go in and you just think up questions right then, right there. What do you think about that? You think you can do that? Well,
It's difficult.
it's very difficult. It is. And so faculty often make this mistake. They think, we'll just have a discussion today. And then they'll think to themselves, I know this content really well. This is going to be fine. But it often isn't fine, because the first time you frame a question and it's framed poorly, the students go, and they sit there. And then one might say, and they'll struggle to say something. But if you can think about what you want to ask them in advance, it makes a big difference. Because then you can think about, where am I leading them? And what are the questions that I should be asking them to get them there? And so actually writing out your key discussion questions in advance really makes a big difference here. And it's a mistake that a lot of faculty make. Just because they think I'm an expert, I can do this. But it's not as easy as you might think. So effective discussion, collaborative learning. The teacher is in a model or facilitator learner kind of mode. The classroom. One of you at the very beginning talked about fear. It was your fear example. In order for this to work, making mistakes has to be okay, and not something that will be reprimanded or the student made to feel bad if he or she is wrong. So a spirit of making mistakes as you approach a complete mistakes are part of learning. That can take away that fear that students will think, I might be wrong. I better not say anything, because I might be wrong. Professor might think I'm stupid, or my peers might think I'm stupid. But if you can create a context where making mistakes, being wrong, is okay, as long as it's on the path to helping you get to the complete answer that you're looking for. So that spirit of making mistakes is okay, making it safe for the students in that particular context. Lots of sharing, summarizing, and processing of the information in a case or a problem of some sort. Okay, so which theories of learning are relevant here? Social construction, very clearly. Yep, emphasis on peers. Teacher is a co-facilitator, so you see facilitator, learner, that kind of idea. So a very socially constructed process. And again, what often happens, which feels good to most faculty, and students like it too, is to vary things. It's also extremely boring to have the same thing every time. You always are going to do the same thing. So it's always going to be a lecture with a PowerPoint, and it's just going to be kind of that. That gets boring and unmotivating. And so to sort of mix it up a little bit in the kinds of things that you do in a classroom setting, drawing on different theories of learning as appropriate can actually make for a more motivating and engaging context. Okay, so here's your task. I would like to ask you to talk to the people you've been talking to, and if you don't have anybody next to you, find a friend in the room. And I want you to think about something you could teach that's short, 5 minutes, a 5-minute topic of in your fields. So something that you would want to teach in 5 minutes. And I want the two of you to decide on this, and then I want you to think about how you're going to teach it. And I don't want you to lecture the whole time, okay? Okay, so the answer can't be, I get up and I talk to them for 5 minutes about this particular idea. Instead, I want you to think about how you would go about teaching that so that at the end, your students deeply understood this information. And because they're probably going to need to use it in some way to do something with it. So, with those assumptions in mind, I'd like to ask you to find somebody in the room and to identify a short little topic, and then to plan a little how you're going to teach it. And I'm then kind of hoping that we'll get volunteers, maybe 1 or 2 of you, who are feeling brave, who will come down and you're going to teach it to us. What do you think? I think it's lunchtime. I gotta go. Are you up for it? I mean, this is sort of, I'm going to try to practice what I'm preaching here and try to make sure that you can do what I'm hoping you can do.
Stacy, would it help if people come closer to the front?
Well, I don't even, it doesn't, I don't mind if they're far apart, but they've got to find a colleague or 2. And groups of 3 will work too. It's hard, it's going to get hard if there's too many more than 3 without shouting down the aisle. Okay? Okay, so I walked around and eavesdropped on your discussions, and I think we have some volunteers. So the first group that I asked last was our colleagues in engineering, two parts of engineering, and they are willing to be our first ones up. I don't know if they knew about the first one part. That they volunteered to come down and teach us something. And here's what I want from the rest of it, from the rest of you. I'd like for you to, and they're being very brave, so we're gonna do what we said. We're going to create a very safe environment for them, and we're going to just provide suggestions and feedback about, what really worked well there, what might be something to think about if you were actually going to teach this, that kind of idea. So with that, I want to invite our two engineers to come down and teach us, and we'll provide you with some feedback. Okay?
Will I be a student or teacher?
However you want to do it.
Okay,
Did you?
Okay. Subject. Okay. Yes.
Am I going to repeat the situation again one more time, or just
So
try another way?
Whatever you want to do. Whatever you think would work best.
You're the teacher.
You're the teacher.
You're the boss.
Okay, the subject is about relationship between antenna size and the operational wavelength or frequency. Okay. Have you thought about the size of the antenna and the operational wavelength?
Yes, there are different. As far as I know,
Okay.
they can be as big as that small building, or they can be very small in their size. So
Okay. Actually, the size of the antenna is directly proportional to the operational wavelength.
what's the operation way?
So the wavelength at which the antenna radiates, use. As you know, there is an inverse relationship between wavelength and frequency.
That's another. Okay.
Okay. So we may say antenna size is inverse proportion to the inverse proportion to frequency, operation frequency of the antenna. And if the antenna is designed in the operational wavelength size, then it may radiate. Otherwise, it may generate a field around it, and it may not radiate for long distances.
So the size is important.
Yes. And
How about the material? Is also important?
yes,
Kind of material.
yes, the material is also important. The geometry, of course, is important, and how you feed the antenna is important.
What do you mean by T?
How you supply the antenna the energy, how you supply the antenna is important.
So how about the distance that is? Yeah, one
Distance,
condition
the
of what is
distance, the distance to which the antenna radiates, or the distance that you may get signal from the antenna you use, is dependent on the conditions in the atmosphere, or the channel, we say, the space between the transmitter and receiver. And if there are objects in the channel, then there may be attenuation on your signal, and they may not arrive at the desired distance.
Okay, this much is enough. I don't know what is attenuation, and I do not want to know. Okay?
Okay. This is very spontaneous. I guess.
Okay,
Yes.
so,
It was not like that when we
Yes,
were
I learned
discussing
something.
the subject.
and I so appreciate that you were willing to do this. So let's talk about this. So let's decide, so what kind of method did he use with his student? Who was a very knowledgeable student, by the way.
It was the
I
difficult
Very
part.
knowledgeable.
more simple.
Difficult to deal also.
Yes,
Difficult to deal.
one of the difficult.
So what kind of instructional method did he use? He used questioning, great. So kind of a teacher-led discussion. And there was only one student in this case, but there would likely be many more. So you probably would have done this in a whole class situation, and there would have been many more students asking the questions. Okay, so he started with a single question. So there was a framing question. Do you remember what that question was?
The relationship between them.
And the wavelength.
Right. So he asked, what is the relationship between these two things? What do you think about that as an opening question? Good? What do you think? It's good. Okay, because it really gets at, I think, what he's trying to do, which is to help his student differentiate these two different things.
Think about it.
And to think about it. Now, and so he led him down a path, a teacher-led model. And so in terms of a theory of learning, what was probably done in here? He did some explaining. He did, you know, when his student said, I don't know what that is, he then went into an explanation of that. Okay, so he then went into kind of expert mode. So do you see what he was doing? He was moving in and out of different theories of learning as appropriate, because the student didn't have the knowledge that he needed in order to do that. So what if he was completely a social constructivist? How would it look a little bit different?
Ask questions to another student.
Ask more questions.
Ask more questions.
About my knowledge,
Yes.
to construct from my knowledge.
Right. And this is a tendency that because we do know, it's easy for us to just answer because we know it. But to step back and maybe to try to pull it out of him, because he may have known more than we think he might know, because we didn't probe very hard in this case. And so sometimes digging a little bit deeper, or not answering the question yourself, but instead doing what? And he couldn't do that. The peers could have come into play here. So a lot of times what faculty will do is if they ask a question and there's a moment of silence, it's called wait time. Faculty are uncomfortable with wait time, so they begin to answer their own questions almost immediately if they don't get a response from a student. Now, he was very responsive. Sometimes what happens is we ask a really hard question and the students just sit there. And we think, okay, I need to talk. And so we answer our own question. And so if you can, there's a couple of things you can do. You can say, this is a hard question, and I'm going to give you a moment to think. Then everybody thinks, okay, it's okay that it's quiet here for a moment. And it kind of eases up that discomfort of everybody's just kind of standing there looking at the professor. And so if you can count to yourself to 5, it often gives you the wait time that you need. So wait for students to come up with the answer. And you might naturally do that. Your student was very responsive, so you didn't have to in this case. But sometimes that question could have been posed to your students, and they might have said nothing. And then the tendency is to start talking, right? To try to avoid that, and to wait so that the students kind of construct that knowledge. So then what would you have done so we had this teacher-led discussion. What would be the next thing that we might recommend that happens around learning this concept?
In my case, for example, I always provide some figures, realistic figures to illustrate the relationship.
Okay.
And ask the students whether, for example, the wavelength that you use in their cell phones, for example.
Okay.
So more realistic examples will be the first step for me, of course.
So you ask them to come up with examples. Do they come up with them?
Yes.
Okay. And then what if they're wrong? What do you do?
Yeah,
Because they probably are wrong sometimes.
usually they ask more questions,
Good. Good.
and it's getting more interactive then,
Yeah. Yeah.
and it may attract students, I guess, because they see something they have in the class.
Yeah. Exactly. And so that's a case where sometimes you just you back up and you watch, and you let the students say, I don't think that's right. I think it's this. And to kind of, then you move into facilitator role, where you're facilitating but not answering their questions immediately. And so deeper learning happens as a function of that. So, thank you. That was great. So a couple of you have volunteered. You can use the mic if you want to, or,
I don't know if we're going to need to.
okay.
Anok will be a student, and I'll be the facilitator. I'm going to pose you some case, and because I know everybody has this conception that, okay, ethics is important, we know, and in the book it says communicating truthfully is an ethical issue, but then that's easy, right? So I'm going to pose you a case, and I want you to go with it. You are a computer salesman, and here comes a customer. The customer is asking for a computer that is not in the market yet. You know that. But the thing is, your paycheck is on sales. The more sales you have, you're going to have more salary. Right. So basically, the question is, will you tell the customer that this product is not in the market, or will you keep this information to yourself? And before thinking about it, I want you to think of 3 principles to guide you whether your decision will be ethical or not. Question number 1 is, I need you to be fair. Principle number, these are principles. Principle number 1, I need you to be fair. Principle number 2, I need you to be acting legally.
Okay.
And number 3 is, if your story with this customer 1 month from now is in the paper, you have to be okay with it. So what will you do?
In my view, I will explain everything to the customer that this is the technology which is present right now, and this technology may come up in next 2 months, and choice is there which one you want to purchase. And of course, if you will purchase the latest choice, you have to pay more because it is the latest one. And thus there may be some minus points because people have not used the latest technology. When they will use it, then they will learn some plus points and minus points. But of course, it is latest in terms of the hardware technology, and you will get an edge in the future, but maybe problematic also.
In the short run.
Yes.
In terms of what kind of
problematic is, for example, there may be some drawbacks in the technology. When the people will use it, then they will provide the feedback. So, but of course, it is the latest one and superior than the existing one.
How about your paycheck?
About the paycheck, I may be a little bit looser in the short term, but definitely if it will be good, and most of the time the latest technology is better in computer, so they will appreciate me and I may get the bigger contract in the future.
So you're counting on the customer to trust you and come back.
Yes, so definitely my approach will be to win the confidence of the customer rather than on the page.
When we do this in class, usually my students go for keeping the information to myself, give the picture.
Well, that's actually what I was going to ask, is that I would think, he's that great,
Yeah.
you really do want to buy something from him because, you know, you've got the whole story, and he's not interested in the, but I'm thinking about the student who says, I don't care about that, I just want to make money. What do you do?
Well, I say, these are the principles of how to make ethical decisions. How would you feel if your case is in the paper? And he said, wow. And I just leave him with that because I can't make him ethical. I can't turn him to a totally different. If he is unethical, and to a certain standing, that way he is. I can't make him. But then I need to like make a little seed in him, plant a little seed that, oh, that's a bit difficult to deal with. Like Uğur Dündar, this famous anchorman, is approaching him. Well, why did you do this to your customer? The customer says, filing a complaint against you. You know, if he's in the TV and all the patient is watching him just because he deprived the customer of that knowledge, he has to feel that sense. But if he doesn't have that sense, how can I implant it?
Yes.
I think we can tell
You
the
teach this
customer.
course to implant that, don't you?
Well, I just have to introduce it, but it takes a long time for people to really absorb ethical values. I have to introduce and keep them thinking. Some of them, they're divided. Some of them say, yes, we have to earn the customer. I tell them, put yourself in the customer's shoes. How would you feel if you were the customer? Cheated. Yeah.
And many times you will find, especially with the insurance agents, they are giving you the policies which are good enough for them to get the good commission, but not good for the customer in the long term. But all are not the same. You will find some good agents also.
Yeah.
So that makes the difference between a good agent and bad agent.
You only have to go through a disaster to figure out whether your firm, insurance company, was good or not. And that's too big a thing.
And in my opinion, we should tell to the students the choices here. You should choose the short-term gain or long-term gain. If you want the short-term gain, you may be good to get the rise in terms of incentive, but you will maybe lose other big contracts in the future. And that's also good value.
Thank you very much. So that was a problem-based or a case-based approach that was meant to stimulate dialogue. And as she said, you know, he was probably the model of what we hope for in business ethics. But it does get interesting when you have students who say, I don't care. It's about me making money, and that's where I'm going. And so that sort of questioning and planting a seed. And she's quite right. This is not something, if you think about constructivism, it really is that this breaking down of their assumptions about what's ethical and what's not does take time. It's not an instant process. It takes time and revisiting that in a number of multiple perspectives to get to that place. But a case-based approach was absolutely, I think in this case, and I think many would agree, the right approach. So, we have time for one more. Do you want, sister? Do you want to go?
Actually, my methodology is was related to case-based teaching, but I can.
Okay, so that was again. Did anybody use a different methodology than a case-based approach? They were together. Were you together, or did you do your separate?
Within 10 minutes we have listened to this. We can concentrate actually.
Okay. Yes. Do you want to do yours?
Modeling your. Shall I model?
Yes. Could you? Would you really?
Hello everybody, I'm from prep school. I'm going to try to model you a typical lesson that is going on, that might go on in a prep school context. The topic is writing, and the subject is writing, and the topic is, let's say, air pollution. And today I'm going to write a paragraph with my class, try to construct a paragraph with my class on the causes of air pollution in a big city such as Ankara. So, yes. And I'm going to pose the problem. There is a problem in some parts of Ankara in winter. If you have looked closely at the sky, there is a problem. The air is polluted, becomes polluted in Ankara, especially in winter time. By the way, what is air pollution, first of all? What do you understand from air pollution? Can you try to think of a definition? Can you say what air pollution is? Talk with your partner for 1 minute. And try to tell me what air pollution is. What do you understand from air pollution? Okay, any ideas? Not clean. Not clean. Good. The air is not clean. Unhealthy.
The air is unhealthy. Okay.
The concentration of elements in the air is changing, and the dangerous one are much more.
Okay. Such as carbon dioxide. The level of carbon dioxide is too high.
Carbon monoxide.
Carbon monoxide, yes. Then we say this is air pollution. Now I want you to think about the causes of air pollution. What are the reasons for this air pollution? Because if we understand the reason, we might solve this problem. Can you talk with your partner and write down some causes that come in
to your mind about air pollution? Okay. Okay. Right. There are too many cars which give off too much fumes and exhaust.
Industry.
Yes, because of industry. Yes. Industrial wastes. We have industrial wastes, especially on the outskirts when there are factories and when they don't control their wastes. What else?
Not enough trees.
Not enough?
Trees.
Trees. There are not enough trees. There are environmental causes. Yes. Okay, now let's keep all these causes in mind and let's write a paragraph together, okay? What should be our topic of the topic of our paragraph? We are going to write one paragraph. So what is the name? What topic? What name shall we give to this paragraph?
Pollution in Ankara.
Pollution in Ankara. That's a good topic. What else? We are going to concentrate on the causes of pollution in Ankara. So can we say causes of pollution? Would you like that? Okay. So now what do we want to do about this problem? This is a serious problem. We want to find a solution. So first of all, if we want to find a solution, we have to concentrate on the causes. So you gave me a lot of reasons. So shall we, what is our topic now? Let's write a sentence, a general sentence, which expresses the idea of the topic. Air pollution in Ankara, or air pollution has many causes in Ankara. So let's make a list on the board about the causes of air pollution. What do you think is the most important reason? We cannot control industry, we cannot control cars because this is modern life. Probably we should begin with the environment. We should, yes, we should plant more trees. We should start a campaign. We should talk with the government. So this can solve the problem. Another way we can solve
the problem? Can it solve the problem? Just planting trees?
Partly it might solve the problem. Because if we have trees, we will have more oxygen. And when there is more oxygen, the quality of the air will improve. So another way we can, let's write the sentence on the board. Another way we can reduce air pollution is to encourage people
public transport.
To use public transport. Yes, we can improve public transportation. In that case,
We can give an example,
Uh-huh.
such as using public transport and giving less money.
Yes, it will
The
have.
municipality can do this. We can give an example.
Right, okay. Yeah, it will go on like this.
Yes, that's great. That's great.
There is what kind of approach, instructional methods? First, I think there was a behavioral way of teaching, like the teacher teaching the student the meaning of air pollution, and then collaborative teaching, discussion, social constructivism, because students talking with each other and sharing ideas, and the teacher facilitating.
Thank you very much. So do you see, she actually did move in and out kind of effortlessly between these different methods, and really, but it was largely a constructivist process and a social constructivist process. And she didn't give all of the answers, which was really helpful. And so we were actively engaged, and we were giving her, responding to her in ways that made sense. And what would have happened in reality is that some people would have said things that were wrong. They would have said the cause of air pollution is there's too many people, or I don't know, some mistake of some sort. And then presumably the other students would say, well, I don't know, or immediately there would have been a discourse around what is and is not a cause of air pollution. So yes.
I think the context is important in this case, for example. Everybody has something to say about this context, but when the course is changed, it is not this much easy to involve everybody in lecturing.
Exactly. So this was a topic accessible to almost
Yes.
everyone. Whereas some of the engineering example, the ethics one was pretty accessible to many of us too. You know, to think about ethics, most of us do. But you're right. The first example was probably the hardest because many of us don't have the knowledge that we needed in that case. So I want to thank you for being willing to do that, and I hope what you came away from is that as you think about where you want to take your students in their own learning, to think about putting more of that on them. Because a constructivist and a social constructivist model assumes that the learner is doing more of the work, and you're doing less of the actual telling and much more of the facilitating of the learning. So I hope that you'll be mindful of that as you kind of move in and out of the use of different kinds of instructional approaches. Hassan asked me to preview at least what's happening this afternoon. My colleague Pratibha will be conducting the session in the afternoon. It's called Designing Courses for Significant Learning. So it very much builds on what we've been talking about. So she'll talk about things like learning goals, objectives, how you think through the connection between assessment and learning and instructional practice. We'll get into Bloom's taxonomy a little bit, backward design. So there's a number of things that will now take you from here's a way to think about theories of learning and get more specific as you think about course design. So that's what will happen this afternoon. And
just one comment or questions. Would you be making these available, these presentations available to
do I
us?
just send them to you or?
Yeah.
Okay.
You can,
Yeah. So all the PowerPoints we'll make available to you, so you'll have the records. Okay. Thanks for coming.
Thank you.
Tonight, what do you say in return? Do I get something back? Tonight, okay. Thank you. Shukriya? No. Meherba. Okay. So this session is really about designing a course for meaningful learning. Okay, that's what we're going to talk about. So I thought, let's hear from you and tell me what you did to prepare for your very first course. When you first taught, when you got your new position, and now you're a big shot professor, and you've got this course, what kind of preparation did you have? What did you do to get ready for that first course?
We TA'd a number of courses.
You did what?
TA.
TA'd?
Teaching assistant.
Oh, so you were a teaching assistant when you were a PhD student. And what did you do as a teaching assistant?
Conducted recitations, read homework assignments, helped read the exams, answered questions, so on and so forth.
Very similar.
Office hours.
What we did, okay. So does everyone who does a graduate course and gets a PhD, do they all do teaching assistantships? No.
He's lucky.
He's lucky?
No. It's if you're not a professional who's also doing a PhD, a part-time PhD, then chances are you will not. But if you are part of an institution and a full-time former PhD students, they won't let you go without TAing a number of courses.
You have research assistantships too, so you can get out of teaching.
Most of our assistantships are teaching assistantships.
Most are teaching.
And those who have outside funded projects can afford research assistants also.
So professors who have funding.
True.
What percentage have funding?
Professor Akai would be the person to answer that question.
Okay. We'll talk to him. So there's a small percentage, probably a small percentage that has funding for research. So everybody else teaches, which is very similar, at least in the sciences. Now, in the arts, that's not common in the US, having teaching assistantships, right? It's more in the sciences, everybody can get some kind of support, and most get teaching, you know, and if you're at Stanford, you get mostly research, but you know, many other schools, you get teaching assistants. So, how many people were teaching assistants then? Oh, that's a good number of teaching assistants, about a third though. So then what did the others do? So you think being a teaching assistant prepared you for being a professor?
I think it helps.
It helped.
Well, and if you're asking what, I also received some in-job training, but your question is before, so yeah,
Well,
TA is pretty much
in-job is once you started being a professor.
true.
Okay.
And that
So-
would be the ASCE in the US has this Excellence in Civil Engineering Education program, which is a 7-day workshop that they teach you how to teach.
They come here and teach you?
No, I was in the US then.
You were in the US. Okay, how about here in Turkey? Is there something equivalent to that?
We're working on it.
You're working on it, yes. We sort of gathered that. So, actually, so I'll tell you, it wasn't that different. Now, I said earlier, I'm really much older than Atılım University. So, you know, when I started teaching, there was very little support. You know. So I finished my postdoctoral fellowship. I did some teaching assistantship, but answering questions, grading, you know, grading exams, those kinds of things. Not really designing anything. I didn't have any responsibility for that. So then I went to a postdoctoral fellowship. I'm a chemist, for those who weren't here this morning. And so I really did 2 years of enzymology, just kinetics and studying enzymes. You know, chymotrypsin is what I studied. And then I applied for a job and I got this job, teaching as an assistant professor, right? So I went in and they gave me the book and they gave me a sample syllabus from another professor who they fired, right? And they gave it to me and I was there and I said, okay, so this is what I have to do. I wrote down my office hours, my name. I was very proud of Dr. Pratibha, so that I wrote that first. And then, you know, I had a list of topics that I was going to go through in the semester. I looked at all the topics that this professor had done and added 2. I said, this is my contribution. I'm going to do a couple more than she did, right? And then that was it. And then I said how I was going to grade, exactly like she was grading. And that was my syllabus. And there I went. So I prepared my first lecture, and I was quite proud of it because I spent a lot of time doing it. But I walked in, 110 students, nursing students, and this was a chemistry course. So all of the chemistry they were going to take it with me. Okay, so that's a big responsibility. And if they didn't get a C, they could not go on to being a nurse because they didn't get admission into the School of Nursing. So no pressure, right? Here I am with 110 students who I could either pass and let them go on or not, right? So I looked at this class and I just froze, right? Because nobody told me what to do. And so I turned around, I had my notes and I wrote on the board. I didn't want to turn and look at them because if I made eye contact, I was nervous, you know, and I figured I was going to make a lot of mistakes. Or they might ask questions. Right? Neither one did I want to deal with, so I just wrote. So what do you think happened? This is how my professors taught me, by the way, in India where I got my undergraduate. Okay? So what do you think happened? I gave my first exam. Half the students passed. They would have passed anyway, whether I was teaching them or not. The other half did. Right? Long line outside my department chair's office, right? Get rid of her. You know, she doesn't know how to teach. Okay, it's fine today, right? I was 28 when I did that. And that's the end of your world. You know, your students don't like you. This is your first job. And so what do you do with that? Well, what I did and what they picked on was her English is not good. They didn't know that I don't know how to teach. They just assumed that it's the English and that's why she's having so many problems with us, right? The department chair was very, very wise and also fair. So he said, I don't think it's her English. I don't think you understand the chemistry. But then he came back and talked to me, got rid of the line outside his office, right? But then they came back and they gave me a mentor and we talked about what I needed to do, right? And how I needed to change the way I was teaching and go slower, look at the students, simple things like that, right? What they didn't tell me still was what was going to produce better learning, right? And so what we need, and this is what got me interested in teaching and learning then, and the whole professional development kind of activities. But I was more self-taught than being taught systematically. Now I know, at this wise old age, that there is really a science to teaching, right? And so why we have schools of education, but the chemists don't go to the school of education to ask what is known and how should we teach, right? The chemists go to other chemists. And so we do the same thing that other chemists did, right? Write on the board and keep repeating that. The other thing that we did really, so actually what I'm telling you is I did everything wrong, right? I was teaching these students who were going to go into school of nursing, but I was teaching them as if I'm teaching chemistry majors, right? So what you really need to think about is, what are these students going to need? And their question was always, I'm going to be a nurse, why do I need to know chemistry, right? If you've ever taught nursing students or you've taught medical school students, they'll ask you that question. There's a very good reason. All of the sciences are very molecular, but we need to teach it that way. We need to teach it so they can see the relevance of it. Otherwise, they keep asking you, why do I have to do this? You know, this is not my field, why do I have to do it? So there are several things that you really have to think about before you design your course, and that's what we're going to talk about. Most of what I'm going to talk about comes from a paper written by D. Fink, and I'm going to give Hassan that article and the reference so he can make it available to you. Okay, so it will be there. You don't need to write everything down. And there are also things, we call them tip sheets. The one sheet, back and front and back, just tips on how to do certain things. So things that Stacy talked about this morning and some of the things that I'm going to talk about, they're all over there. So let's have a conversation. Don't spend a lot of time writing because you're going to get all the materials that you need. I do want to apologize. I have asthma, so I'm going to keep drinking water, so it's going to interrupt a little. Okay. So when you think of a course, when you're designing a course for your students, what you're designing is a series of learning experiences, right? That all are interconnected or integrated. So they're not isolated pieces, they're all built on each other. What do you think about when you plan a course? Or what should you think about when you plan a course? Where does it fit in the curriculum? Remember I said, you know, these are nurses. And where does this course fit in their curriculum, in their whole development as a professional, right? This is the only time they're going to see chemistry. What do I want them to learn from it? What do I want them to take away? And how do I teach them to think like a chemist in that one-year sequence? What textbook, right? That one we always think about. That one is the first thing to think. Which textbook can I use? So it's all there and I don't have to prepare too much, right? So we do think about that, but there are several other things. What kind of assessment, right? How am I going to know when they've learned something? How am I going to assess that? How many can I do in a 15-week period, right? How many assignments can I do? So those 2 extra topics that I added, I never got to them because I didn't even get through what the previous professor had done. But I figured I'd do more. The more I put on my syllabus, the better I look. That's what I thought. And how much content can I cover? So can you cover everything? Chemistry, especially chemistry and all of the sciences, change every day. Can you cover everything that is out there? Or do you want them to learn how to learn everything that's out there and everything that's going to come? Because if science is done right, it's not going to stop growing today. It's going to keep changing, right? So where do I start? So this is what I was talking about, Fink 2003. He's got a terrific paper. It's a nice little package. It's with activities in it, you know. And most of this comes from there. So you really want to design your learning goals. What do you want the students to learn from this course, right? What are the objectives? And we'll come back to that and talk a little more about how you design goals and how you put together objectives. You want feedback. You want to give feedback to the students, but you also want to know how you're doing, right? You want feedback for how what you've designed, is that working for the students? And of course, how you're going to get the students to learn what you want them to learn, right? So those are all your teaching lessons plans, you can call it, teaching activities, lectures, or other cases, whatever, right? So what you need to do is establish some learning goals, right? So given the context of your teaching situation, so I already talked about it, right? What was my teaching situation? Nursing students taking this course because they have to, right? They probably have some high school background, but not a lot. All female, okay? That was an important piece of information. They were all female. Many of them were in there. Once they got comfortable, then I started to learn all this. Many were in there because actually their father or their mother or somebody told them, you can't be a doctor, so go be a nurse. You know, that's easier. That situation in itself is a hindrance, or it makes it difficult for the student to learn because their self-esteem is lower, you know. So what is the situation? What are they dealing with? Most of my students also came from a working class family. So there were very few role models at the home. They were mostly firemen, policemen. That's the neighborhood that we were in Chicago. And those were the students. So first generation college students, that's important. You know, if you've got, my mother had a graduate degree. So it's a different mindset. You've seen somebody go through that before. Not those students. Okay, so that's a different situation too. So what do you do when you know all that? Or you should know what to do when you know what your student's background is. So look at bullet number 2, the topics, right? That's what I did. I listed all the topics I was going to do, A to Z, significant figures, structure of the atom, went down the list, right? Are there any chemists over here? I've got, I can see you smiling through this, so I sort of guess that's what we do, right? Now, why do we teach significant figures? It means nothing when we first start, but we start with that. Anyway, that's a different topic, okay? So, you're going to design a course that produces significant learning. Then you've got to think about a lot of the things that actually Stacy already talked about. So we're going to tie this back. And I think through the week we're going to keep going back to the learning theories and, you know, what should people know and how do they know. So foundational knowledge. Now we know in chemistry you need foundational knowledge, right? You don't know the names of the elements and you don't know what an electron is and what a proton is. You're not going to be able to progress. Okay, so you do need that. Just like if you want to read, you have to know the alphabet. So there is some foundational knowledge, and that comes from memorization and making it part of your brain so you can draw on it automatically. You don't have to think about it all the time, right? So then you can do bigger and better things. Applying your knowledge. So application of knowledge is just as important, or I mean, and it's a higher order thing. So managing a project, being creative, thinking of new ways of applying your knowledge, right? Looking for patterns and developing skills. How does a chemist, or how does a biologist, or how does a historian think about the discipline, right? Those are things that we have to develop. Integrating things, connecting things, seeing patterns, right? Looking at it in a different situation. All of those things are learned, and the more practice you give your students, the better they get at it. Some students will, you probably have 10% of the students that are going to do well in spite of you. But they'll actually do better if you give them better experiences. So we're still losing a lot of potential. Sometimes people tell me, at Harvard, we don't need all this, right? But what I say is, think about what those people could do if you did have some of this. Because even there, where you're straight lecture, and we had a professor from Harvard, Eric Masur. How many have heard of Eric Masur at Harvard? Somebody you want to look up, because he's a physics professor but does a lot of education type of work. And he came to it late because he thought his students didn't need it. And then when he tested them, that's when he realized everything he thought they understood, they didn't understand. They got A's, but they didn't always understand. So anyway, we need to think about those things. And then on the other side, the human dimension and the caring, and Stacy referred to this already. When you learn, when true learning happens, you change. So there is that human dimension. You either care about you care about the environment, or you care about the people you're learning about, or when you become a nurse, you're going to be more compassionate, whatever. But once you get educated, you change. You're never going to remain the same. So there are things that, and the ethics, so we already had that discussion this morning too about ethics in your courses. So all of that is your personal growth and your personal change. Now somebody asked me if I was going to talk about Bloom's taxonomy, and I am a little bit, but some of what we just said overlaps with what Bloom's taxonomy talks about. So, the cognitive, this is about knowledge and development of intellectual skills, right? And then you have the affective, the emotional aspect of learning. And Stacy, please chime in anytime I'm missing it or not saying it all. And then there's the physical. Depending on your field, you have to do it. If you're going to be a surgeon, you better be coordinated, and that better keep getting better as you go along, right? So there are those motor skills, the coordination, depending on, well, if you're going to be a football player, you better be well coordinated. So anyway, there are different dimensions. We're going to stick mostly with the cognitive for our discussion here. So if you look at the cognitive, the bottom of the pyramid is the foundational knowledge, and then as you build on the pyramid, your level and sophistication keeps increasing. Now, Stacy was telling me there is a debate about whether synthesis should go on top and evaluation should be before that. And certainly, it depends on, I think, you can evaluate, if you're going to evaluate a situation, you need to be able to do everything. On the other hand, synthesis could, maybe they can be next to each other, and sometimes there, and sometimes, because it depends on what you're doing. If you're synthesizing a lot of information, and you put it all together, you may still have to evaluate what is the worth of this, right? So I could go out and look at all of the literature and write a terrific review article, but then if you look at the evaluated, who did it benefit, and was it really worth the trouble, So in that case, I think evaluation comes on top of the synthesis. So there might be other things where it comes before. So what this is doing is, if you're going to be testing as a teacher, you're going to be looking at their knowledge, right, and defining objectives as to what they should be able to do if they have learned your subject. These are the verbs on the left-hand side. Those are the verbs that they should be able to do. So, for example, again, I'll go to chemistry, but that's what I can think of, is, this is the name of the compound, common name. If you match it, you're going to match it with the IUPAC system, which is a systematic way of naming the compounds. Okay, that's a matching. Labeling things. If you've got a diagram or you've got an anatomical figure and you have to label it, okay. Making a list, all of these are knowledge kind of things, like basic knowledge. Okay? That's what you want. On the right-hand side, that's what you want to be able to build into your activities so they can do on the stuff on the left-hand side. Okay? So if you go through the same for comprehension. Again, I'm not going to explain all of these, but what do you want them to be able to do? Right? This is the verb. Go ahead and say it.
And so what's on the right-hand side are the strategies that we talked about this morning. Remember, for those of you who were here, the information processing model was very much about helping students to figure out how to learn something. So the verbs that are associated with each of the levels of Bloom's taxonomy, those translate to those kinds of learning strategies. So on the right are really strategies, some of which you may need to model for your students, and they may not know how to do a concept map, for example. So modeling concept mapping and so forth.
And really, if you go through, some things are more appropriate for one discipline than the other. So like flow charts are very common in chemistry, You go from here to here to here to here. Paraphrasing, not so much, but students explaining is very important. Okay, we don't do enough. Those of us who are chemists, we don't give them enough to explain. But when do they learn how to speak like a chemist? If you don't give them that practice, So using the language of chemistry or using the language of history or biology or whatever. So anyway, having students explain visual representations, again, this is a very common misconception in most of science. The students don't see that all of this empty space, which we think is empty, is full, and it's full of particles. So if you tell them to draw what does this room look like, their pictures never match what the reality is. Very few actually match what the reality is. That these are individual molecules floating around. They don't see that always, So again, visual representation is very important to seeing whether a student understands what they're seeing and what they're learning. Same thing with application, right? So again, you've got all this. Do you want to talk a little about the cognitive apprenticeship? Because that would be a little, how do you build in cognitive apprenticeship in your teaching environment?
So do you mean what is cognitive apprenticeship? So in a lot of fields there is kind of a whole practice around how to do something. So a cognitive apprenticeship would be to really sort of put yourself in that role and have to then think like that person. So it can be in a variety of fields. We tend to see it in more practice-based kinds of scenarios where the idea is to immerse the students in that context and then to have them to think and function as if they are in that role. So, and it's one where it's a very social constructivist kind of model, where it's not Pratibha telling everybody how to do something, but rather that they're learning it as a function of being in that particular environment.
So, and in the sciences, again, and engineering or any, you have that in the labs, and you watch your professor thinking through things, and you watch the older graduate students doing things, and then you learn as an apprentice, just like you would in an art place, or as a carpenter. You're actually doing the authentic stuff as the professional in the field is doing, okay? And authentic situations, that's another one that I want to talk about just a little bit, because way too many times in the laboratories, in the labs, we give them a procedure. Follow this step by step by step. You go from A to B to C to. Why? We never sometimes we explain, sometimes we don't. Sometimes they get it, and most of the time they don't, you know. And so why do we do that? But if you actually gave them a real life experiment, that has no answer. See, most of the labs, you know when you make something, this is going to be the melting point, right? And then you're grading on, okay, did they get the melting point? Were they 5 degrees off? You give them 5 points off or 10 points off. That's not authentic, because when you do chemistry in real life, that's not an authentic thing. So you're building a skill, which you'll say is important, but you can build the skill and still give them something that's authentic, which means they don't have the answer. So then how do they go about getting the right answer? How do they build confidence in getting that answer? That would be authentic. How does the scientist know something is right? We can teach that to the students, and then that's an authentic experience as opposed to them knowing they have to go to 200 degrees. Well, then they'll get it. Eventually they'll get it. Case studies, we already had some examples this morning. So anyway, we talked about some, and some are newer. And these are, of course, a higher order. Again, all of these, and there are too many to go through individually. But again, you know, how do you bring that? What do the students have to do to be able to demonstrate some of these things? There you are, writing journals, writing notes. That's one of those other things that people don't always do, and they're very effective, is writing down what you've learned and writing how you're progressing in your learning. That's very important there. Debating something, discussing with others, persuading others as to are you right? And why are you right? What's the evidence for what you're saying? Those kinds of things, you know. Decision making is very important. You've got 2 or 3 different ways to go. Especially in organic chemistry, you'll come across that all the time. You're going from A to B. There's 4 different ways to get there. Which is the best way? Which is the greenest way, right? Which is the least hazardous way? There are many different ways to go from A to B. And how do you decide which is the best way? And if you're working for a pharmaceutical company, they'll say go the cheapest way. Never mind green, never mind hazardous, go the cheapest, right? There are different ways of making decisions, but they need to know the merits of all of those. So anyway, we're back to designing our course, right? You need to start with what do you want them to learn, right? So you need to be able to write some learning objectives. My time is coming to an end. I'm going to have you do some of the work now. So what's the difference between writing a goal for your course and writing objectives? Now you can, just what Stacy had you do, please talk to your neighbors and then share some of the ideas that you came up with, okay? So what we want to talk about is what's the difference between a goal and an objective and how they relate. Now I want to hear a lot of noise.
What is the broad? It's a broad thing. Small, bold,
right, but not yet.
So many objects.
Let them, we're going to talk for 5 minutes, so everybody has a chance to talk about it, and then we're going to talk, then we'll come back, okay? So do we have some consensus out there? What's the difference between a goal and, yes?
I think objectives may be some steps for achieving a goal. Objectives may be sub-goals of our main goal. Is it correct?
Do you agree? Do you agree with what she said? Yes? Did you have anything to add to that?
Some parts is okay, some parts is poor.
Some parts okay and some parts is...
Some categories, but based on instruction design model approach.
Okay,
and
so do you want to...
maybe enable objectives and objectives, but both. Just for both things. And also for both, but include several objectives inside. Then each objective has one, behavior. and then also you can have another behaviors under these objectives.
Okay, so
Gain this objective.
can somebody give an example of what he's talking about? You go close.
Objectives can be taken as expected student behaviors at the end of the course.
For each goal.
We're identifying, yes, we're identifying and explaining the behaviors that the students will be able to do at the end of the course or activity, whatever it is. And they are expected student behaviors.
Can everybody hear what she's saying? Can you hear? At the back? Okay. Yeah. So, and those are measurable. You can
Measurable.
measure them, right?
Yes.
That's important.
That can be-
You can measure it. So,
And observable. Observable and
Observable.
measurable.
so you know, Dr. Kai said earlier today that I worked at the National Science Foundation, and when people submit their proposals, they had to have goals and objectives. And I'll tell you, very often, they were not clearly defined objectives. And so what happened is you didn't know whether the proposal, whether that project was going to work, because we didn't know how they were going to measure it. And of course their evaluation was off because they were talking about objectives that were not, that you couldn't measure, right? So it's very important really for, in all aspects, not just from the learning point
And
of
the
view.
objectives can be used or must be used as evaluation criteria at the end.
Right.
So they
Right.
are predetermined, they should be predetermined very carefully so that you can use at the end of the course or term for evaluation,
So-
as evaluation measures.
Exactly. So this is why your objectives have to be very clear. Not just to make your job easy to evaluate, but also for the students to know what they need to know and what they need to be doing and how they need to behave at the end of this, right? So if, sure, so that's exactly what the difference is. So just to summarize it, what you said already, right? Everything you just said. That goals are much broader, right? You started out saying that they're bigger things. And so, you know, I want in organic chemistry for the students to understand the relationship between structure and function. But that's a big goal. That's the field, and it's growing in that direction. Is the biggest contribution organic chemistry makes to the world is relating structure to function. Now, how am I going to measure that in the students? So I have to look at each little thing, right? Can they do conformations? Do they know stereochemistry? Do they know what's chiral? Those I can measure. I can tell whether the students know whether this is chiral or not. But structure function is very nebulous, you know? Can I do that? Well, they have to demonstrate it in small things like that. Okay. So objectives are much more precise, right? And they're more tangible and more concrete for students and for the teacher, right? Okay. So you use objectives to build the foundation for a course, and you organize your course concepts, things that you're going to get across around your objectives. So you want to know how the students are going to behave when they know this. Well, then you can design your learning activities around that. How are you going to teach them to do that, right? How are you going to teach them to think like a chemist? That's a big goal. Now you have to have these objectives on what do the chemists think about the particulate nature of matter. Very simple. All of matter is particles. Do they get it? Well, you have to design your activities so they get it, right? Also, they present, like we said, they present a map to the students, and they link the expectations to teaching assessment. So that's what your good characteristics of good objectives look like. Can you read this back there? It's very hard to tell from here. Can you? Yeah. Okay. So they have to be unambiguous, right? They have to be clearly written. They should be observable, measurable, just like you said. results oriented, right? So you know what it's going to look like. This is what the result is going to look like. This is how the student is going to behave when they think like a chemist. Thank you. I'm going to come back to this in a minute. So I'm going to skip this second. Right? This isn't. So really, when you write objectives, right, you want to write them in, like Stacy was talking about earlier, they have to be student-centered. What is the student going to be able to do? So here are some examples of that. Look at the one on the top. I will have the student solve the last 5 problems in the chapter. That's very faculty-centered, right? I'm going to make them do that, as opposed to the students will correctly solve 3 of 5 problems at the end of the chapter. They don't, if they're not full-fledged chemists, they may not be able to solve all 5 problems. If they're not mathematicians, they may not be able to do it. But if they did 3 and did it correctly and understood it, would that be a good thing for this, at this level? Yes, right? So that's what you want to be looking at. And they need to be realistic. Again, I will go over the method of solving a problem, then only I will learn that equation. The students may not learn that equation if I do it, right? So students will demonstrate the correct method of solving an equation. That's different from I will. That objective at the top is my learning goal, not theirs. My objective, not theirs. And I will have students work in groups, come up with 10 important events in American history, as opposed to the students will learn how to work in groups. So you get the point. So now what I'm going to have you do is create a few objectives. Okay? So again, if you work together, we need the lights on again, I guess. Can you work together and create 5 objectives for your course? And then we'll share some. Okay, so I'm doing 5 minutes. 1 objective per minute. Together. Okay, do we have a few objectives? Now who wants to share them? You didn't give them the answer back there, did you? You didn't create the objectives. Okay. Do you have objectives you want to share? Yeah. Okay. Are you going to share some? Who's going to share? Oh, you are? Okay.
We wrote some objectives for a civil engineering design project course. The students will be able to identify and quantify design loads. The students will be able to build structural models of a building with a specialized software.
Now, is that measurable enough? Is that
if
narrow enough, or does that need to be broken down into 2 or 3? I need help from the engineers.
We thought it was measurable enough.
It's measurable enough. You get good. Okay.
Take my word for it.
The students will be able to design the geometry and reinforcement of structural members based on analysis results. And finally, the students will be able to effectively communicate their design in written and oral form.
There's a lot there that's exactly right. The one thing I think that may be where you were going, Pratibha, is the how will you know if they've done it well enough? So sort of that criterion for what's success, I think, is the piece that you just add a little bit more. So you did have the word effectively in your last one, but in other cases you didn't have something where a student who did it kind of okay and someone who did it really well. What's the difference there? And that part isn't quite there, I don't think.
So I'm thinking as a student, if I'm your student, how do I know when I can get an A, and what do I need to do to get, get that top grade that I need, you know, what do I need
think
to
the
know?
evaluation criteria are defined and attached to each of these objectives in written form so that they would know
Yes.
what takes them to an A versus what leaves them at B.
And that is a way that we do that often, is that we will have a whole rubric, for example, around how we would evaluate something. There's usually something, some criterion of some sort that we usually see in an object.
Some more. Thank you. This is good. Yes.
Ours is to do with language teaching.
Right.
Because the subject matter, when the subject matter is unfamiliar, we can't, make comments much.
Right.
The topic is writing ability. We said by the end of the lesson, the students will be able to write topic sentences for their paragraphs. This is an objective. And then we continue writing objectives for a paragraph. And then the ultimate goal is students will be able to write essays, reports.
Essays, reports, but those are broad.
This is the goal. The
goals
goals are the goals.
So what's the objective then?
Topic sentences, supporting sentences, concluding sentences, excluding irrelevant ideas from a paragraph, and so on. The ultimate goal is essay writing, report writing, story writing.
So you start with, put the goal on the side, and then you've got all these objectives there.
So
That was
are your
this whole
comments
group here?
still valid in this case?
It still is, I think, is what's a good topic sentence versus a not so good topic sentence.
It has a controlling idea. Maybe then we can say a topic sentence with a controlling idea that
Yes.
controls the content of the topic.
Exactly. So a little bit more specificity helps a student because they might think they wrote a perfectly good topic sentence and it's not.
It's not.
Yeah.
That includes the topic and the controlling idea.
Right. And that's then relevant to the rest of the essay, or that frames the essay, or however you want it to, but that is
More
what your topic
information.
sentence does. Exactly right.
Okay,
Yeah,
thank
and
you.
that, defining it like that helps you give them feedback too. Give the students feedback then, instead of saying this was not a good topic sentence, you can give them more information as to how to get it better.
Like an exam question, in fact. In the exam, we need also to identify the criteria for a topic sentence. Okay.
Are there any more objectives back there?
I can ask a question.
Sure.
If you wish, I tried to in fact design a senior graduation project for software engineering, but there's a basic problem of how to measure the quality of software. There's a well-known problem that is, we are talking about the measurement, and we wish that those students to be able to just produce some software product, and you are asking that you have to be able to measure that, but how?
Were you able to measure, were you able to evaluate how good that product was that your software engineering students were?
Maybe this is related to the maturity of the field. I mean that the
Right.
software engineering field is not mature enough to be the classical engineering field for. Is it clear what I mean? That is,
But
if
how
you
do you
wish,
evaluate it
in
then?
anyhow you always subjectively. I mean, in terms of performance or the space requirement, that is memory usage and etc. Maybe this is a special case that
Well, but
software
that's more objective than some of what she was saying. With the memory space and how much they require and how, I couldn't break it down in your field, but it seems
but
like what you
user
said.
friendliness is one of the requirements that you have to achieve, for example, nowadays. But there are many different efforts to be able to just measure that. There's a measurement problem there over. That is not everything is measurable. In subjectivity, anyhow, you have to be in that. I mean that with your experience somehow, if you have just developed such software, you'll be able to measure it in a better way. That is the measurability is the basic problem. Maybe especially in our field. I don't know the other fields, but the product quality may not always be measurable in that case.
But if you look at the product quality, if you look at 3 different products, how do you evaluate in your mind which one is the better product?
Yeah, there are many perspectives.
There are many, it's subjective is what you're saying, but it's
Yes,
also where it's going to be used and for what it's going to be used, then for that purpose is that good? So
The
you
user
can-
requirements can be the focus. That is,
Right.
if whether that user is satisfied in terms of their requirements, this can be one measure, but it's still subjective.
It is subjective, but you're still, in your mind, you're still thinking about something when you're evaluating them.
Yes, I give the grade by the end.
Yes,
by the end I do some AABA,
so your thinking
But I
has
don't
to
know
be
how.
visible to the students.
Yeah.
You're thinking about something when you're evaluating those things. What are you thinking of? Those are the ways you're measuring them, then those become your objectives. But I as a student need to be able to get into your mind and see what is it that he's evaluating, what do I need to do?
Why do you like it?
Why do you like it? Yeah, when you say you like it, why do you like it? What is it about this project you like?
If this would be an art course, how do you evaluate? I mean, for the artist,
For an artist, yeah, so they have objectives. They absolutely do. And they do.
Are they measured?
Yes.
I have maybe a solution to that, if you would consider that a solution.
A little bit louder. Okay.
If you would maybe open up your projects, those softwares that are eventually designed at the end of the course to the rest of the engineering students and make them vote on it through a web page, whether, I mean, if they could use them, if you're measuring user friendliness, the number of votes would just tell you which one takes the most
Yes,
attention.
we already do this because that is interactive. They also do a website for their projects. Plus, by the end of that course, we are just making a jury coming from the industry to evaluate the quality of those contents and etc.
But your jury too is following some rules. I mean, I'm not, yes, go ahead.
We can solve this problem easily. I understand very well. And we can create just control list and which one is good, which one is as objectives all and how you create this document or product and lesson, web design, etc. Everything is going to be possible as a part of CBI lesson. You can create just control list by the expert and then you can apply the student as a graduate or other people. You can get feedback and then definitely you can create very perfect, product or document or any software package. But of course, every time there is a measurement mistakes. Errors. It's going to be possible.
By
Is
the
another information.
Yes, we are already doing this in this way, by the way.
Yeah.
I said this step by step.
So I put that back because it does define the B, C, and D are the things we're talking about.
Right.
What, under what conditions under degree, what is the standard for acceptable?
Right.
So you skipped that. So I brought that.
Thank you.
Yeah.
Are there any general questions about whatever we've talked about? Because Hassan said that there were going to be cookies and tea. So we are going to take a cookies and tea break, and I'm hoping you'll come back for the next half. Okay. Did anybody get tea besides us? I understand that there was no tea out there, right?
No.
Sorry about that. I was told there was going to be tea and cookies, so I announced that. I think they said there wasn't enough notice, so starting tomorrow we'll have it, right? That's the information. Sorry about that. So we're going to talk a little bit about the kinds of activities you need to put in so it matches your learning goals and objectives, right? So a lot of what Stacy talked about. So this is really a summary of that, and then we're going to go on and do something else. No, I'm way too far.